Let me open everything I need to open. Today we have boring programming stream number 4. As usually, we are both on Twitch and YouTube. And we'll start in 2 or 3 minutes. Are we live? Yes, we are. Okay. So, the plan for today is to, since I'm on Linux, I can upsolve some problems, I can do some coding. In particular, I'm going to upsolve this problem. Link to this block on code forces you can find in the description below the video. So you can also see this link. It's a problem from a recent code forces round that I didn't have time to solve. Not so hard one, I think diff1c. What else? Practicing Bernstein's lemma that I learned on the last boring stream. Finding good tutorials about Gaussian elimination. So this, I know Gaussian elimination, but I want to find in the internet good tutorials about it to see how others explain it. And then yeah, the second point is to find good tutorials about other topics too. And reading IOI syllabus. Okay, hello Karan. Can I discuss about FFT? So what I can do is, there is an echo I think. Okay, let's check that. 1, 2, 3, 4, 5. 1, 2. Hello, Maxi. Mucha. Let me check for echo. Yeah, there is a huge echo. One, two, three. Okay, what about now? 1, 2, 3, 4, 5. The echo is terrible. Okay, second try. 1, 2, 3. What else can I do? I can turn off the microphone for a minute, then try again. One, 2, 3, 4, 5. Now we are on camera microphone. And now we are back on microphone Yeti. I think I must turn on and off and on the whole OBS, but then the stream will stop for a moment. So now I think there is no echo, but my voice is distorted. And now digital input, and now microphone input. Okay. So this one was better. 1, 2, 3, 4, 5. Okay. I can experiment later more, but it should be fine now, more or less. I thought that after figuring out glitches, Linux will be okay, but it is not, apparently. Who's that bear on the window? It's a puzzle, magnetic puzzle, where every piece of a bear is a piece of puzzle. And so yeah, and the black rectangle works like a fridge. It's metal. Hello everybody, greetings from Mexico. Here is 3 a.m. Okay, hello Daimel. So I guess it's not that you woke up at 3 a.m. I guess you just go to sleep late. So let's see how long can you last. Let's move to the actual content. And maybe first thing, I will check what happens when I stop OBS, and can I stop it so that the stream wouldn't stop. OBS stopping stream. Could you please fix the sound issue? So the sound is still bad, we're saying. Let's check that. When practicing, what do you think is the optimal time to try to solve a problem before seeing an editorial? Try as long as you have new ideas. How can I fix it? Yeah, so let's check that. Can I exit OBS and then open it again and not stop stream? Looks obvious. Echo. Let's mute that. 1, 2, 3, 4, 5. And the other thing I can try. Okay, now I created some sound with computer. Test, test, test. What didn't help? Stupid Linux. Audio output, audio input capture. 1, 2, 3, 4, 5. I changed settings in OBS. Okay, I will So you don't see what I'm doing on the second monitor, where I have OBS and I'm experimenting with settings. Sound was alright at the start. The question is, what changed? Okay, now a different type. 1, 2, 3, 4, 5. Microphone test. Is it any better? Ten minutes of dealing with issues, sound issues. Again, sorry about that, guys. Let's try removing this. Still a robot metallic a bit, yeah. 1, 2, 3, 4, 5. Now you shouldn't hear me. Now you shouldn't hear me. I'm muted completely. No, you still hear me. Sounds cool, emo. Okay, let's remove this. Let's remove that. Do you hear me now? 1, 2, 3, 4, 5. So I've turned off sound in OBS and you still hear me. Here, 1, 2, 3, 4, 5. One sound has been fixed. I think there is no difference from a few minutes ago. Okay. Let's test this. I think now the sound is bad, and now it was good, and now I think it's bad again. Okay, so it's bad now, and now it's fixed. It's awesome. It's amazing. 1, 2, 3, 4, 5. Okay, so note for the future. Desktop audio here should be turned off for some reason. Okay. So maybe I should write this down. I had this document for notes about streaming. No. On Linux. Desktop audio should be muted. Yeah, and let me also make sure that I'm on Yeti microphone. 1, 2. Now it's on. Okay, awesome. So what can we do first? Practicing Burnside's lemma. Let's start by solving a problem. So there is that C from round 539. I can paste a link in the chat. So there are some queries. Change some event, delete the event, and take some interval of events and say what happens for that interval. I guess drawings will be useful if I want to explain something for you as well. And my tablet isn't working on Linux now. That's funny. So what we have here, an event is starting from some time, tap speed will be equal to S. So there is some tap that pumps water, either with positive or negative speed. Negative means that it takes away water. And we wonder, given some starting value V, starting volume of water, we wonder when is the first moment when the volume of water will reach 0. So just if there is 100 units of water and the speed of tap is 5, then it will happen in 20 seconds. Because the speed is 5 per second. And we should either say -1, what means it will never reach 0, or we should print the first moment. And we can't binary search, because also the speed of tap can be negative. So the graph of the volume of water can look like that. It's not necessarily decreasing. And I started coding something during a contest, but I didn't finish in time because I solved other problems instead. How was this contest? So without unofficials, I was 7th, so I skipped C to solve D instead, because D was about counting trees and I'm good in that. And then I went for E. That was some data structure problem, I guess. Because after solving D, it would be stupid for me to go to C, because solving only A, B, C, D wouldn't give me a good place. So here I would be like, what, 20th? So that was a good choice to try E instead. And then F was some very hard problem. Yeah, I remembered. I didn't know how to do it after a few minutes of thinking. So after solving E, the contest was 2 hours and a half. I had 25 minutes for C, and I didn't manage to do that in time. And I had some code, maybe I can find it, but I think I overwrote it when participating in the last contest. I hope I will be able to turn my tablet on. To make drawings, and even without drawings I can start coding. Let's put that on the right. I can close codes from the last round. Then I hope this doesn't cause glitches. What this is? Let's move to another directory. And let me copy my templates. Here we go. I can decrease camera a little bit. Okay, that should be better. What's the issue about the tablet? So I have this Wacom tablet that doesn't want to cooperate right now. I'm trying to remember if it worked last time with Linux. Or I messed something up. What we have? We need a struct for sure. So I will build a segment tree over some events. This is what should usually be done when we have queries like add an event in some moment, delete event, and then ask about interval. The perfect structure for that is a segment tree. Also, to know how to... Numbers are up to 1 billion, but what I can do first is read everything, sort by values, the times that will... all the timestamps that will ever happen, and then I can sort that and build a segment tree over those values. So I think it's called data compression, or what? Values compression, coordinates compression, I think that's the word. So we need to do this. I already did that during a contest, but I didn't save my my file. So let's read the input, the number of queries. Then the queries are what? Vectors. Let's read the whole line. So type the number of stuff, or for every type, let's do something separate. Here read T and S for type 1. Queries pushback type TS, and also values pushback the time. Time is what? T, the tip second. If type is 2, then just read T. To queries we add type and T, and to values we add T. Type 3 is LRV. Here both L and R represent timestamps. So queries pushback everything, type LRV, and values pushback L, values pushback R. Else assert false, because I think every type should be 1, 2, or 3. Here, so I created vector of values, and here I sort them and remove the repetitions. Function unique removes repeated consecutive elements and returns the number of them later. So here after that, let's see, debug is my function to print something. Let's print it before and after removing repetitions. Let's copy the tests. Here, unnecessary space. Okay, and C run on into and in 3. So here we have a lot of values, 2, 4, 1, 6, 1, 6, and so on. Then I remove repetitions and I have sorted 1, 2, 4, 6. Good. Then what I need? Do I need to add time 0 or time infinity? I don't think so. Then I need a struct that I usually call S. It could also be node for an event. I need when and volume, but since this will be a segment tree, I will also need like, what is needed in a root of such a tree if I'm asked about the whole interval. I often think about that for segment trees. So a segment tree should be able in constant time give the answer for the whole interval from 0 to n-1. This information is stored in the root. So in the root, I think I should store, so given then value v, the initial volume, I should be able to say in the root whether the answer is -1 or not. So in particular, I think I need minimal volume. This is if we reach this interval and we go through this interval, when going through this interval, what is the minimum point we will reach? Assuming that we start from 0, let's say. Then this value can be, for example, -5. Minimum volume, maybe something else. Hello Kamil, good luck on that problem. I waited. Okay, thank you, Karim. When volume, do I need when? Maybe not. Then why do I need volume at all? In a leaf I need volume, I think. Let's try that with drawings. How can I try drawings? without a tablet. I can draw with my mouse. Maybe a grid will be better. No, it will not. Okay, so every segment represents a linear function, and for such a segment, here will be that minimum volume. Here I assume we start from 0, and we say if we are allowed to go up and down, what is that minimum volume? So here we have minimum volume. Just please not this font. Chewy. Open source. Okay, this is minimum volume, and given that if we are in some node, we know whether we'll go below 0. Then I guess I will need a recursive function, just like usually in segment trees. Do I need lazy propagation here? I don't. Maybe I don't need a recursive function. But I need for sure a merge function. I need to be able to merge two nodes. So this is left node and right node. My min volume will be minimum of left min volume and left total change delta plus right min volume. So if here I have such a piece that gets from 0 to, let's say, -5 to this point, and then here in a second piece I have something like that reaches a minimum point of -10. -10. Beautiful. Then together I will have -5 in the merged function. So apparently I also need delta. And the total delta will be the sum. Next. I think I need longs. Let's use longs for everything, because values can be up to 1 billion, but times volume can be up to 2 to the 18. I wasted about 2 hours to solve that problem with dynamic segment trees, and after 2 hours I realized that it is incorrect approach to solve problem. That's it. How do you debug? Well, I print values and see what is wrong. Please can you elaborate in a descriptive way? I will try to. So for that I need better drawings. Let me try plug my tablet in a different port. Okay, so now you will not see my camera because I plugged it off. what suggests that my USB port is broken. And that's bad. I don't have a hub. So I must plug off something, and I need microphone. Well, I can use microphone from camera, maybe that's better. For now, I don't have a camera. Okay, just I hope you hear me. So I can draw. Yeah, I can draw. Let's do a full screen. So the whole thing, what we are given in the input is some function. Let's say here there is moment 0, then here with volume plus 3 we go to moment 5. Then here the I can also put axis here. Maybe a smaller width will be better for this. Okay. Here we go. Let's change that back to 4. There is some moment here. Let's say it's t. Then here it's t plus 5. So here we had 0. Here we have 15. Assuming that the volume was plus 3. Then we go from this new place down, maybe with volume, I don't know, -1, then -5, and so on. All of that is a function that is called piecewise linear. So every piece is a linear function. Then for the whole thing, if I want to build a segment tree on that, I need to figure out what I need to store. -10 is looking good. So I don't have this -10, yeah. For the whole thing, I'm going to store the point where the function reaches minimum point. So this would be here. This is min. Then what else I need? So this I need to, in a segment tree, to do some like binary search to know whether, I think in a whole tree, if let's say they ask me about the whole interval from 0 to n-1, and n I assume for now is 4, then I start from the root, and I wonder, and I am given some v0, volume 0. I wonder where is the answer? So where is a point where I first reach 0? Then I ask this vertex, the left one, if I go there and I only consider this interval, what is the minimum point? So it's kind of like asking some part of this function here, what is your minimum point? It would be this one. And I ask, and I check if this is like -10 and v0 is 12, then I know that I will not reach 0 in this interval on the left. Instead, I must go to the right. And when going to the right, I know if I will ever reach 0, it will be in this interval. So this is why I knew that I need that minimum volume. Also, when I wanted to implement a function for merging two nodes, I saw that for minimum volume I need delta. What means, can I scroll this? I can't. Let's remove something. How can I do it? I can just create a new sketch, but when I merge two segments, like this one and this one, to know after merging these two into the following one, so this was the left part and now this is the right part, and so this right segment knows that assuming that this is 0, then this is -10, and this left part remembers this is 0, this is -2. Then after gluing it, I will get here point -12. So actually what I know is that by adding that left part here, I move the whole right segment function down by this value, or up by -2 or down by 2. So this is why I figured I need something, I need this delta. So delta is total change of volume after going through this interval, and minimum volume is minimum, like lowest point reached in the process while going through this segment. And then when in volume, I will think later, do I need them or not, like timestamps. Congrats with getting black red, thank you a lot. Now delta is delta plus b delta. What I will need, let's later finish this function and the whole struct. And what do we do here? We just process queries. I need a function that, given a timestamp, some x in this value, it will convert it to a value from 0 to n-1 or something like that. This will be lower bound, values begin, values end, x minus values begin. So if I got that, like here, the vector of values 1000, 2000, 2002, then given value x equal to 2000, I will get 1. For this value, I will get 0, and for this value, I will get 2. This is the coordinate compression. Now, for every query in queries, type is query of 0, and no, if type is 1. Let's open the problem. Add a new event means that starting from the 10th second, the tap speed will be equal to s. So this turns some leaf on. Then here we have delete event, which is only easier, and something else. Now, I need to decide whether my tree will be built on points or on segments. So change color. Should this be a leaf or each of those points? This is an important decision, and I'm not sure about it. So I think it's easier to merge intervals, to think about merging intervals rather than points. On the other hand, the queries from the statement are about turning points on and off. So what happens initially? Let's think. Initially the speed is 0, I guess. I will assume that at least. So I want to work on segments, not on points. But for that I need to do some extra work because the queries are about points. And for example, if the function looked like this, and then this point was cancelled, this one, then we remove this segment and instead we say that this speed continues, I think, because this query remains and it is from this moment the speed is something. So I think I will hold these times of when something changes in a set or a map, and I will do something with that. So map speeds. No, starting from 0. Yeah, starting from 0, I will say that the speed is 0. And in inf it's again 0. Inf is 1 billion plus 5. Also to values here, let's add these two. I hope it makes sense. Now, when a new point appears, what happens? I had some function, like I need a pen, like this function, and then what happens when a new point here appears and its speed is something like plus 4. Then I remove this segment, and up to this next point where something changes, I have this speed, and this moment is copied above. This is moved here. So when this is a new point, I need to find this previous point to shorten the segment. What I have, t is the moment, this is query of 1, and new speed s is query of 2, because this is what I've read here. Then in this map I need to find the previous point. Speeds, what, lower bound? Can I do it like that? Lower bound. Now I will put a pair, whatever, t0 minus it, and this should represent the previous point. It's here assert it not speeds begin, so that I could decrease by 1. This should now point to the previous thing. Previous is it first, and its speed it will be it second if I need that. Does it compile for now? Warning, couldn't deduce. Here I need, I guess, or just t, because only key matters. Yeah, okay. Now only warnings about unused variables. The previous is that. Okay, so segment tree is built on segments, not on points now. I need to go to the leaf in a segment tree representing this time and to say to him that his segment is shorter. So it will be like 3 of, this will be power of 2. Let's create that. Base is 1, while base smaller than values size base times equal 2, and this is now a power of 2. And this will be 3 of size 2 times base. Base plus get ID of the previous. This will be that ID leaf is base plus get ID of the previous. Okay. 3 of ID leaf. Let's say init. And here you should be from the previous to current t with speed, well, with your speed, it second. Now for a node in a tree, init will get starting time t0, ending time, so makes sense, yeah, okay, t0, t1, and speed. Then delta will be casted to long t1 minus t0 times speed. Mean volume will be mean of 0, that is in the first point, and delta. So if a segment looks like that, I say that here we have a minimum, and if it's increasing, then the minimum is here at 0. What else do I need? I need something for a leaf. So if we are in leaf that looks like that, and maybe not like that, maybe the decreasing one, we start with some initial volume v0. We need to know when exactly we will reach the volume of 0. For that we need, I guess, starting time, so this will be that when starting time, and volume, maybe speed is better. Here I will give speed is speed, and start is t0. I don't need to store end, I think. When I merge two things, so some leaves are empty, they don't represent anything significant. Let's represent that by having start equal to -1. So if a start is -1, this is b, else if b start is -1, this is a, else the real merge. When I initialize the tree, I will put, like, all the vertices will be fake, so will represent nothing. Then tree of the first leaf will be init from 0 to infinity with volume 0. Okay. Let's make a function to update everything from something to a root. So init leaf, actually, with id, starting time, ending time, and speed. Tree of base plus id will be dot init t0 t1 speed. Then for everything on the route to the path to the route, do merge. Here we'll have init leaf 0 from 0 to infinity with speed 0. And then here init leaf, this will be get id of t previous, t0 is t previous, t it second. And then init leaf, get id of t from t to the next time. Let's do that in a moment with speed s. So this is that new event, and for that let's here increase it by 1 again, and this should be that lower bound. So here it first should give us that next moment. Speeds of the fifth. Yeah, I think so. So here that it first represented the previous time. Now after increasing by 1, this is the next time to which our segment goes. The last thing is that I should do speeds of t is s. So 2 types of queries to go. What is the next type? Remove something. This should be similar. T is just query of 1. Auto it is speeds. Let's find t. Let's assert that it first is t, and this should be available there. Now minus assert it not speeds begin, because I want to decrease. In t previous is again it first. In speed previous is it second, plus it. This is the next thing. Time next is it first. Speed next I don't need. Now init leaf, get id of t previous, that one. It now starts with t previous up to t next with speed as previous. But first let's do init leaf, get id t. No, it should be removed. So what? -1, -1, -1. This should remove it. In here initialization, I think it will work. So something will happen here, but anyway, start will be set to -1. Okay, and finally speeds remove or erase. I think erase of t. Else, so this was else if type is 2. finally, if type is free, then do something, and else assert false, because we have wrong type, or invalid type. The last thing to do. You should simulate the process from the beginning of the 11th second till the very beginning of the 11th second inclusive. So we have some L being query of 1, R is query of 2, and volume 0 is, maybe this should be long. Volume 0 is query of 3. Okay. Now if v0 is 0 immediately, then we just print L, because the volume is 0 initially, and we continue. I wasn't sure about this, and I actually asked a question during a contest, and they answered that yes, then this moment is when the bowl become empty. Well, it doesn't become empty, so this was a bit strange in the statement. So it should become equal to 0, but initially it is 0 already. I wasn't sure about that. Now otherwise, we are looking for the first moment that this happens. Let's gather in a segment tree, let's gather vertices representing this interval from L to R. L plus equal base, R plus equal base. Let's store them as pairs int and s. So every pair will represent index in a tree and the struct, or just maybe int is enough. Left to right, left pushback L. If L different than R, then right pushback R. Now while L is more than R minus 1, if L is the left child of something, then left pushback L plus 1. If R is the right child, right pushback R minus 1. L divided by 2, R divided by 2. This is a standard thing. Now reverse right, and for everything in right, push back to left. So now, after this kind of standard thing, in a segment tree, do we have a drawing for segment tree? Let's make a bigger one. In a segment tree, what we have is hop, hop. Given some segment, I gathered vertices, like the left path was everything that was on the left, starting from this guy. So I think I gathered this vertex, let's say, and on the right path I gathered these two. So these three vertices together represent the whole interval that I'm looking for, and so these two were in vector right in my implementation. Then I reversed that and merged the two, so now I have them in order 1, 2, 3, so from left to right. And there, what I need to do. How to move it? I can't. Let's leave the drawing open. For everything on that list now, if tree of ID mean volume is smaller than v0, smaller equal v0, then from this vertex, we should go down. Otherwise, v0 minus equal 3 of id delta. Because we know that this segment decreases volume by something. And here if, so let's say int, I don't know, found -1. Here we'll do found is id and break. This represents, okay, now if found is vertex from which we should go down, if found is -1, then puts -1 and continue. Rohit, I will check that problem later. And otherwise we go down from this vertex. So while let's say that it's id, while id is smaller than base, so not a leaf. What now? Also let's do if 3 of id start is -1, so this is a fake vertex. Actually, let's create a function for that and continue. Let's skip this one. Here I need a function is fake. Return start is -1. So here actually this is fake. Is fake means, actually I think is empty would be better. Represents a segment without anything. Now from this one we go down. If my right child is not empty, if not fake, and 3 of 2 times id mean volume smaller equal v0, then id is 2 times id. Otherwise, if that one was not fake, then volume minus equal it's delta, and we go to the right child. Okay, now we are in a child. Let's assert that this is not a fake leaf, and let's print answer is 3 of id find exact point. That will get v0 and print answer. What was it? Get find exact point. Find exact point v0. Assert I'm not fake, and print return v0 divided by speed. I think starting time plus v0 divided by speed. And here I will assert that speed is negative. Yes, I think so. It should be negative. So this will be actually divided by minus speed. So what negative value means? The tap speed will be equal. Positive value means that we decrease the volume or increase. Pumps as liters of patients per second. Okay, I think it's okay, and let's run it. I expect some asserts to fail. Yep, exactly. So let's analyze this sample test. Does it also fail on other ones? Yep. Even on in3 we got some out of bounds, so let's investigate that first. I got index 1008, but container only holds 16 elements. So I used somewhere, instead of get ID, I used just T. Do I see speeds find T? This is fine. IT initleaf. Everywhere I should use get ID in initleaf. Get ID, okay. Here I don't. So this should be get ID. Okay, answering queries is harder than I thought. Could you talk about persistent binary search trees like persistent IVL and persistent tree, please? Maybe I will do that one day. But maybe what I can do today, because I planned something like that, is researching good tutorials about it. So, you know, generally about almost everything there are tutorials online. It's just about finding something of good quality. Get ID here. So the thing is that I answer a query starting from some point, and this point doesn't necessarily exist. What I might have to do is splitting some segment into two. Now this is the next thing. My assert IT is not speeds begin minus minus IT. T previous is IT first, as previous is IT second. Okay, maybe if ball special split is IT first is different than L, then I need to do something extra. If special split then all of that. What I need is initleaf get ID of T previous from T previous to L and as previous here. Okay, and then initleaf get ID of L from L to T next with my speed. What speed? The same speed. I just splitted one segment into two. Okay, but I need to do the same for R or do something else. Let's with GDB also check where is a mistake right now. In line what to 206. Here tree of ID is fake. So left contains some stuff that is not in the boundaries. Why? What did I push to left? Okay, makes sense. So eventually I should do something like, maybe I can do that first. Okay, now I need to do get ID of L, R is get ID of R. Maybe to do remember R. Let's solve a problem without R. That should be better. Without R, and instead let me copy this file because I might need it later. Memo cpp. I don't need R. Then only left is needed. Else greater than 1, L divided by 2. If L modulo 2 is 0, then left push back L plus 1. Then I found all. I now consider interval from L to the end. I don't need this. And when I print, I will say if answer is smaller equal query of 2, so R plus 1e minus 12, then print this. I hope this epsilon is enough, and otherwise print minus 1. So I just check at the end whether this found first point is smaller than R. What happens now? Still issues. Okay. So what I think I need to analyze the first test, this one. Debug type query. Okay, the issue happened for the first query of third type. I initialize, I set two leaves, then something bad happens. I want to be able to print, so to print this node as how to write it, debug operator dd name of start, name of speed, min volume, delta. Something is wrong. It should be as dot. So I print attributes of that struct. Now I think I can print from 0 to 2 times base. I can print the node. Okay, I got a lot of values, and it will be hard to analyze this. Let's make this a little bit shorter. I want to get even shorter tree to analyze it better. So maybe now I get, yeah, still I'm getting an assert. What about here? 0.1. Oh, awesome. Now my tree is only of size 8 and it's easier to analyze. So I need to see what is printed. I can do it here. And sketchpad. Here we go. Hey, hello, Rishabh. So we are solving problem C, that is on code forces block. What happens here? From 1 to 6. Let's analyze our tree. Tree has 4 leaves. We have vertex 1. I don't need to print vertex 0. Where do I do it? From 1 is enough. Values are 0, 1, 6 and infinity. So these are 0, 1, 6 and infinity. In the first query, starting from 1, I set speed equal to 1. This should be in this one, in 5. But so this is before the query and this is after a query. So from 5 I have start 1, speed 1, and this goes up to infinity. I think this line looks fine. New volume. Okay. Wait, assertion speed smaller than 0. But what about this? I think I see a mistake. What if the answer is -1? Minus volume smaller equal. It should be smaller equal minus V0. So if V0 is 5, then I need to get minimum volume -5 or smaller. Here as well, minus V0. And that's it. Okay. Let's compile without my debugs. I don't think these are correct, but at least I don't have asserts. Oh, here I have one. Okay, it isn't so bad. So I guess I need to see why I have here an assert. Oh, In which line? 63. 63. So in find exact point, I assert that speed is smaller than 0. Why is it bad? Let's here before that run debug id tree of id v0. v0 is already negative. It shouldn't be. It can never be negative. What about this? Is minimum volume for sure smaller than delta? Let me assert it here. Tree of 2 times id min volume smaller equal tree of 2 times id delta. If not, then something is wrong. So how did v0 become negative? Okay, left, if is fake, continue. If min volume smaller than this, then do that. Otherwise here let's as well assert tree of id min volume smaller equal tree of id delta. I don't see how v0 could get negative. Assert v0 greater equal 0. Assert 0 greater equal 0. In line 217, here it was negative. Is it positive here? It is. So it still breaks here. If this is fake, then do that. Okay, otherwise assert min volume is smaller than delta. Debug v0 and tree of id, just the whole tree of id. v0 was 1. Okay, it should be plus. And it should be plus here as well. Let's try down now. Okay, I have some new values. For first one it's okay, for second one it's okay, and for third one I don't have here exactly the same thing, but maybe it's because they don't print it with so good precision. Let's try submitting that. If possible, I don't want to spend more time on this problem. And let's wait. Running on test 1. What do we have here? Yeah, so here I didn't like the fact that someone said we are giving prizes, and he didn't say whether it's for all the countries. Running on test 4. Okay, so I passed samples. If I fail another test, I'm going to just see what test it is. It's of course cheating a little bit compared to the contest. Wrong answer on test 9. Hooray. Expected -1, found 18. First number differs. Okay, so what is the first? From 18 to 25, volume 5. That's strange. Let's copy this. Maybe I have some overflows. And here, 1, 2, 3, 4, 5, 6. 6. I print 18 while the expected answer is -1. Okay, I think I remember what else I was going to change. So here I split something into 2. Later I must fix it back. How to fix is if special split, then I need to remove that fake point, and later before continuing here, so ending the whole loop, I need to run fix, and where else? Here as well, because I added a fake point. Now how does fix look like? I need to remove that, so it is speeds find L. What now? L should be again query of 1 in case I change that. It is this, T previous is it first, as previous is it second, init leaf get id of T previous up to some next thing, so here plus it it first, but this happens only, so I messed something up after making a query, so this can't be an issue here in this test. So this fix will not fix the correctness on this test. T first and as previous, and also init leaf get id of L -1 -1 -1. Something, but let's assert here that it first is L. Let's just return here. Okay, so something is wrong in fix. What is it? Find L. Assert it different than speeds begin. Assert it different than speeds end. Again, let's use GDB. 194 this line, it first, so assert strange it different than speeds end. Okay, this assert fails. Special split if special split happened, then I don't add to speeds here. Speeds speeds of L is as previous. Now, okay. So still something is wrong. But let me run it on samples again. Okay, samples are fine, and this test is not fine. I can remove these two. Would that change something? Okay, still I will remove these two as well. Okay, and now why do they say -1? Let me take someone's submission to make sure. So standings, Omnic, his CPP, the solution seems similar, by the way. Now his run on in4, -1. Why is it -1 on this test? Starting from moment 12, I have speed minus huge. Then I ask, starting from 18 to 25, when will I reach 0? When I start from 5. What is wrong? Why is answer here -1? I think I should read the statement. What happens if here it's -10? I think it should be 18.5. If we pump with -10, then it will become 0 after some time. Now, after half a second, it's empty. But why if we start... Oh, we only consider... we only consider stuff from this moment. Okay, we only consider events from this moment. So this whole split was unnecessary. I could do... I could just do query like L is speeds lower bound L first, and that's it. That was much easier, but I misunderstood the problem. We only consider events in that interval instead of the previous one. Or L is inf, then we do that. So the whole split thing is unnecessary. So I printed infinity. It shouldn't be infinity. Samples are fine. If L is infinity, then print -1. Okay, so the problem wasn't that hard. I did a lot unnecessarily. Other than that, it's doable. So because I thought that the last event before the given interval also matters, I've took that previous segment and I've split it into two. What is wrong in second one? Okay, I missed something here. Okay, so here I print 7 instead of 5. Because I commented that. Did I need it after all? Speed L. What I do? L is speed lower bound of L first. Okay, but still this is still true and should be done first. If is 0 at the end, then do that. I don't have v0. Okay, let's submit. Congratulations for becoming LGM, thank you. Still, this problem was for sure more complicated than an average C. And it was optimal in this contest to skip it. And time 300 milliseconds. So instead, in more than an hour, I did, here we see that we did E, which is worth more points. And it's also data structure related. Okay, so the first point from my list is done. Maybe not the first one, but one of the points. This one. Then I wanted to find good tutorials about Gaussian elimination. I think I will do that now. Just let me turn the camera on.